So hi everyone, in this video we are going to solve this particular problem on GFG. The name of the problem is max dot product with zero intersections. So let's see what the problem description is saying. So we'll be given two arrays with the name A and B of positive integer of size n and m respectively, where m will always be less than or equal to n. So the size of the second array will be either less than or equal to the first array, and we are allowed to insert zeros anywhere into the second array so that its length become equal to n. Okay. The dot product of the two array of equal length is defined as the multiplication of the first element added to the multiplication of the second element and so on till the last element. So we need to return the maximum possible dot product of the two arrays. Okay, so if we want to maximize the dot product of the two arrays, then in that case, what do we need to do? We need to make sure that we are multiplying the maximum number with the maximum number and the minimum number with the minimum number. Let's see what do I mean by that. So let's take the first one as the example 2, 3, 1, 7, 8 and 3, 6, 7. Let's say these are the two arrays that are given as the input and we need to maximize the dot product. Yeah. So 2, 3, 1, 7 and 8. These are the elements that are present in the array, and this is the array A, and the array B will be denoted as 3, 6 and 7. Now we can add as many zeros as we want anywhere in the array B. So we can add zeros at any position in array B. So we can say that we can multiply 3 with any of this number and then 6 with any of the number to the right of that and 7 with any of the number to the right of them. Yeah, and since all the other number are going to be 0, so I'm multiplying them with the number like any number in the array and adding that to the result will not give us anything. So we can ignore that as of now. So basically our goal is to make sure that we need to multiply the element from the array B in a way such that uh, we get the maximum sum as a result. So how can we achieve that? Let's see. So if we we have how many choices over here? So we can multiply 3 with 2, we can multiply 3 with 3, we can multiply 3 with 1, 3 with 7 or 3 with 8. So we have this many choices. But once we multiply 3 with any of this number, then we can't multiply 6 with the number that is there in the array A to its left. So if we multiply let's say 3 with this 3, then we can't multiply 6 with 2. Yeah, why is it so? Because suppose this is the array 2, 3, 1, 7 and 8, and suppose after inserting the zeros in the array B, we are getting 3 and before 3 we have a 0. Let's say this is 6 and this is 7. This one is also 0. So once we fix the position of the in element 3 in the array B, so we can say that okay, before that there could be multiple zeros, that is fine, but we need to make sure that okay, again one more thing which I forgot. So we need to make sure that all the elements are like those are remaining in the array B, they should be multiplied with someone. So 3 has three choices. 3 can either get multiplied with 2 or 3 or 1, because 7 and 8 should be reserved for the other two, because they must be multiplied with some of the element, because we can put only zeros in the array, but we can't say that okay, we are not going to multiply 6 and 7 with anything. So that's one thing. Okay, so for 3 we have how many choices? For 3 we have 3 choices. So if we multiply 3 with 3, then we can't multiply 6 with any of the element that is on its left. So we need to find an optimal way to multiply the elements from the array B so that the result gets the maximum value. And how can we do that? Let's see. So one of the approach could be this one, that we are going to see for each of the combination, like 3 has 3 option. So after multiplying 3 with, let's say, 2, after multiplying 3 with 3, after multiplying 3 with 1, how many possibilities are there? So after 3 is multiplied by, let's say, 1, we have only one choice. So 6 can be only multiplied with 7. Yeah, let's try run this one. So let's 3 is multiplied with 2. Then how many choices we have? We have for 6 we have 3 choices. 6 can be multiplied with 3. 6 can be multiplied with 1. 6 can be multiplied with 7. These are the 3 choices that we have. And if we multiply, let's say, 6 with, this is going to be a bit lengthy. So let's say we are going to write it over here. So 3 has 3 choices. 3 can be multiplied with 2. 3 can be multiplied with 3. 3 can be multiplied with 1. So if 3 gets multiplied with 2, then 7, like 6 can be multiplied with any of the these 3. If 3 gets multiplied with 3, then what choices do we have for 6? We have only 2 choices. We can multiply 6 with 1 or 6 with 7. So 6 multiplied by 1 or 6 multiplied with 7, because we need to keep one element remaining for 7 as well. And if we multiply 3 with 1, then for 6 we have only one choice. So for 6 we can only multiply 6 with 7. Again, if we multiply 6 with 3, then 7 has 3 choices. 7 can be either multiplied with 1, 7 can get multiplied with 7, 7 can be multiplied with 8. Yeah, these 3 choices are there. We multiply 6 with 3. Yeah. Now if we multiply 6 with 1, then how many choices are left? 7 has 2 choices. 7 can be multiplied with 7. 7 can get multiplied with 8. Now if we multiply 6 with 7, then we are left with only one choice. That is 8 multiplied by 7. Now if 6 is multiplied with 1, then 7 has 2 choices. 7 can be multiplied with 7 or 7 multiplied with 8. If we multiply 6 with 1, Then again, okay, 6 multiplied 3 into 3, 3 into 3. So 6 into 1 or 6 into 7 should be 6 into 3, so 6 into 1 and 6 into 7. Yeah, should be 7. So if 6 is multiplied with 7, then we have only one choice, that is 7 can be multiplied with 8 only. And if 6 is multiplied with 7, again we have only one choice, that is 7 is multiplied with 8. So out of all this, which one is going to give us the highest amount of result? Let's see. So this one over here is going to give us 9. This is 128. 9 plus 6 plus, okay, this one is less. 9 plus 6 plus 49 is also less. So, so here is 6 plus 42 plus 56. This one is 68, and this is, again it is less, so it's 6, 18, 6, no. So I think 128 is going to be the result. Let's see. Oh, 107 is the result. Why? Why not 128? 6 into 7. This is working right. 3, 3, 1, 7, and 8. Let's say 3, 6, 7. And we insert zeros at this position. Then 9 plus 6 plus 6. Yeah, it should be answer. 656 100 and 12, 121 should be one answer. This is what it will. Okay, so that's why it is 107. Okay, got it. So this is one approach that we can use, but this is not going to be able to. Okay, this might be helpful, or maybe not. For each of them, how many possibilities can be? 10 to the power 3 into 10 to the 3 possibilities in the first case. And what can be the depth of this decision tree? This can also go to 10 to the 3. Okay, I think this will work. Yeah, 10 to the 3 into 10 to the 3, that will come under 10 to the 8. So this might work. No, why am I saying that? It will work. Yeah, by using memoization, we can reduce the number of redundant function call, and we can uh, get the answer in the optimal time. So the state of the DP is going to be pretty simple. So this is the array A and this is the array B. So for each of the array, we are going to check for this index. What are the maximum? What is the maximum result that I can obtain starting from this J? Like from J, we can go to right, and what is the maximum result that I can obtain for this I and for this J. So this is going to be the state of the DP. So DP of ij will be the maximum dot product we can get from I index in B and no, from I index in, let's say, just for simplification, I index in A and J index in B. Actually, it should be allowed just for easy. Let's say this is I, this is J, because yeah, I will always be iterating and J has to be there for each of the possible values in A. Yeah, you can put anything over there, but just for my uh, understanding, I'm going to put BI and AJ. So let's say AN is the size of the array A and BN is the size of the array B. Let's create the vector of the DP. Okay, so the first one is going to be I. This is B. This is A. And we are going to update this value whenever we get any maximum value. So the minimum value should be -1. Yeah, why not? Because dot product cannot be negative since we can always multiply it with 0 and all the other number are going to be positive. So that's why if we keep it as -1, this value is going to get updated whenever it sees any other value. Okay, fair enough. Now what we are going to do? Now we are going to do the function calling. So we are going to start from the very beginning where I and j both will be 0. So let's say I and j both are going to be 0. So let's go here. Now what we are going to check, for each of the I, it can be multiplied with all the possible values on A. So how many values can it be multiplied with? Let's see. To see that, we need to first check that what are the remaining values that are there in the right of I. So in remaining in B are the number of elements that are remaining on the right of the ith index in array B. So bn minus I minus 1. These are the number of elements that are present on the right of uh, ith index. And what are the number of elements that are remaining on the right of j in the array A? So int remaining of A is same for n minus j minus 1. Now we are going to check how many possibilities are there. So if at any point of time which is not going to happen, let's see, following that, let's see. If at any point of time remaining of A, remaining of B is greater than remaining of A, then in that case we are going to return dp of ij as minus 1. Yeah. Otherwise, how many possibilities are there? So one possibility is what always going to be there, and how many more? So the more possibilities will happen only if there is a difference. So if in the array A there are more number of elements remaining. If they are same, then there is nothing that we can do. So for int k equal to I, k equal to 0, k equals to possibilities, k equals Since we are going to get the maximum value, let's say max is minus 1, or we can save it in the DP as well. Let's say 10 plus I, I plus k, also with the plus k. A, B, B. So one possibility can be to add the number. So dp of ij is going to be multiply the ith element in A, and multiply the ith element of B with A. Also, just for the memorization, we can say that if dp of ij is not equal to -1, okay, it is giving time limit exceeded. Is there any way we can fix this? Let's see. Okay, so here we have two options. We can either choose the one that we previously had, that is multiply I with j, like multiply the second index with the fourth one, or we can choose to multiply this with 7. So 7 can be multiplied with 7. So 7 multiplied by 7 is 49, and since we previously had 56, so that is the larger one. So we are going to put 56 over here. So we are going to fill the DP table like this. That way we don't have to use this extra for loop that we have used. Yeah. Then again for here, let's say 2 to 2. So from 2 to 2, we have three options. So we can either 7 multiply 7 with this or this. So we are again going to choose 56. Then again for 7 with 3, we have 4 choices, but still 56 is the largest possible value that we can make. Same for this one. So in each of the steps we are going to do this. We are going to check if the previous one is larger, and if not, then we are going to update the current value with the multiplication of the ith and jth uh, element of the A and B array respectively. So then again, for this value, what we are going to do, let's set 6 and this. So what can we do? So we have only one possibility. We are going to add 56 with, we're going to add 56 with 6 multiplied by 7, 42. This is where we are going to, yeah, 56 plus 40. This is not the valid one. So 56 multiplied by 40, 56 added to 42. Here we have the option. We can do 56 with 1, but that is not required. So 56 plus 42 is how much? 98. So 98, 98, and this is the largest value that we can. Now from 0, we have some of the option. From 0, we can go to 2 and multiply with 1. So that will give us 98 plus 3, that is 101, but that is not the largest possible value. So we are going to check here. We are going to check here. This one plus this one. 3 multiplied with 3, which is 9. That is bigger. Yeah, that is bigger. So we have here 98 plus 6 or 98 plus 9. So 98 plus 9 is the one that is going to be the result. Yeah. So this is the table that we are going to create and fill. So now we have to call the function where we use the tabulation approach. So this was the minimization, which is by filling all the table entry one by one by using recursion and function caller. Now we are going to see how can we approach this problem by using tabulation. Uh, so here again I will be starting from the end of the indexing weeks. Okay. J will be starting from I, right? Somewhere else. So first we need to check how many remaining elements are. So we are going to use this one. Mass, the number of elements that are remaining, that will tell us from where the J should be starting. And we need to check if there is any maximum value. So, to J, because for this one there is going to be nothing, but for this one we need to add 56 with the 42. So now max is there, so we need to multiply max with the current element. What is it? Multiply with add. check if there is any value that is better than ours. So if we have identified so should be so this. Let's print the DP. Okay, 154. This should not be 150. What happened over here? So it was solved. So we are doing this thing wrong. Like we are checking for the one that is just uh, below the row at the uh, jth column, but we should have checked it the diagonal way, like the one that comes to the comes in the table just right below the number. Like I hope it makes sense. I was not able to explain it properly, but yeah, it was a good problem. Thank you. Bye.